We're going to look at the derivative of log e x. Now, log e, specifically e, when you derive it, you get 1 on x. So it doesn't matter what's inside as well. If there's a k or anything, it's still 1 on x. So, yeah, just simply put the rule. To find the derivative of each of the following, d dx, that does not look like a d, of 3 log e 2x gives us x. Remember, any multiples go away. B, we have 3 log e of square root of x. Now, you have to use the chain rule here. So, we have let u of x equals to square root of x. So then we have du dx equals to half x to the power negative half. Then dy du is 3 over u. Well, no, it's 3 over square root of x. So therefore, if we put it together, d dx of 3 log e square root of x is equal to a half, and that's square root of x on the bottom, times 3 over square root of x. So that's 3 over 2x. C, we have log e sine of x, so same thing, use the chain rule. So let u of x equals the sine of x. So then dy du is just 1 over x. Du dx is cos of x. So then dy dx, oh, well, it's not really a y, but so therefore d dx of log e sine of x is equal to cos x over x. Okay, D. So with stuff in between again, it's the chain rule again. Yes, I was going to cut this down, but figured it would be good if you guys see different examples. Because you guys are watching this on video, feel free to skip ahead. You don't have to watch this whole section if you understand what I'm doing anyway. So dy du is 1 on u. Du dx is 2x minus 7. So then we have d dx of that whole thing. Hopefully you guys aren't watching it on a phone and you can't see anything because it's so small. There you go. E. So we have a quotient rule one. So remember the quotient rule. Oh, I always forget the quotient rule. B du dx minus u dt dx over b squared. So let's let u of x equal to log e of x cubed. Then, sorry, I'll do this on a different side. Give me a sec. Right, let's do this again. So minus u dv dx over v squared. That's the rule we will need, the quotient rule. Then let u of x equals log e x cubed, and v of x equals to x squared minus 1. So then u dash will be 3x squared over x cubed. So that's 3 over x. And then b dash of x then be 2x. So then b dx of that whole thing was equal to v, and then du dx minus u dv dx all over v squared. Now, in terms of optimal ways of writing, there is no real optimal way of writing unless I tell you to write stuff in a specific form, in which case I follow it, but otherwise you can usually leave it as where I've left it. Alright, so now we have a product rule one, where we have an x cubed plus 1 and then a log e x minus 1, because the two of them are multiplied, so let u of x equals to x cubed plus 1. Then the derivative of that is 3x squared. v of x equals to log e x minus 1. And v dash of x is equal to 1 over x minus 1. So then putting that together, d dx of x cubed plus 1 log e of x minus 1 is then equal to, so v du dx, so 3x squared log e of x minus 1 plus u dv dx, so that's x cubed plus 1 over x minus 1. The graph of a function 0.5, sorry, f of x equals to 0.5 log e x minus 1 is shown. State the domain and range, find the value of the constant, find the gradient, and find the equation at the tangent. Alright, so domain and range, this starts at 1 and goes to the right. So that means our domain of x is equal to 1 infinity. Now just keep in mind, that that is an asymptote, so it will never cross. That's what that dotted line means. Current range, it's all real values because it goes from negative all the way to B, find the value of the constant A, given that A is 0 is axis intercept. Easy, make it equal to 0. Then go through and solve it. So you might then ask, what do we do when we get to this point? Well, you've got two choices. You can either A, rearrange it so that you get everything in terms of E, like so. Or if you remember, log of 1 is equal to 0, so you could just put that way as well. Anyway, each of our 0 is 1. 6 minus 1, move 1 over, so we get 2. So then A is equal, I say A is equal to 2, and then I write down a 0 because I'm thinking ahead. Anyway, B, find the gradient of a curve at A. So f dash of x is 0.5 over x minus 1. Remember, we have to substitute it, find the derivative, etc. And you'll get x minus 1. If you're not sure, you can go back and watch. You can try it yourself. Then substitute 2 in, which we then get 0.5, or if you like a half. So then D, find the equation at the tangent. So y minus 0 equals to a half x minus 2. So that's y equals to a half x minus 1.